everyone and welcome back to my channel Be Yourself. This is Dr. Rajni Sharma and today we will discuss about the thermodynamics. Actually, yesterday I already have uploaded this topic in Hindi. Then I got some of the comments to upload the same topic in English. So again I am repeating this. So let's start what thermodynamics is. If we talk about the thermodynamics, there are basically two terms, systems and surrounding. System you can say is your sturdy material. As we are focusing on the thermodynamics, so we can say that we will study here in the system how temperature is variation is varying or energy is varying. So in any system, variation is brought about by the surroundings. It will be influenced by the surroundings. So suppose here E1 is the internal energy of the system. Then suppose Q amount of energy is given to the system by the surrounding and some W amount of work is done on the system by the surrounding. Then what will be the change in their internal energy of the system? Then we can express it here as here E2 is the change in energy. It will be equals to the E1, which was the initial internal energy of the system, and the Q amount of heat which was given by the surrounding to the system, and W amount of work which was given were done by the surrounding on the system. So when we will minus E2 minus E1, it will give change in internal energy of the system, and it will be equals to the heat given by the or energy given by the surrounding or to the system and the work done by the surrounding on the system. So there can be conditions that here we are just expressing that Q is given by the surrounding on the system and W amount of work done by the surroundings on the system, but there can also be possibility that some of the Q amount of energy is given out of the system and work done by the system. On that case, formula will be same, only their signs get changed. How? If suppose Q is the work is the amount of energy absorbed by the system, then here we will use a positive, and when system will release energy, definitely their energy will be decreased. So instead of plus, we will use here minus sign. Similarly, for the work done, when work done will be done on the system, then we will use a positive sign, and when it will be done by the system, then we will use here negative sign. Suppose here we have a gas cylinder which is having a piston over it, so that we can control the volume of the gas, because we know that it is a property of the gas that it will occupy whole of the space of any container in which it is placed. Suppose initial volume is V1 or in the gas cylinder, gas volume is V1. So when we will apply force and we will pull off the piston, and now the position is here, piston position is here. In that case, it will what, when we will shift is by amount L amount upward the piston, then the volume will also the gas will also occupy this volume also, and now this time the volume become V2. So what is amount of force is applied by the gas on the piston, because here the gas is expanding, so it will apply force on the piston to lift it up. So we know that the pressure is, how we can calculate here force. We know that pressure is equals to force per unit area. So force is applied by the gas on the piston, and A is the area of the piston. Okay, so here what will the force here? Force will be equals to pressure into area. Now what will be work done by the system on the piston, or work done by the gas on the piston? It will be, we know that force work done is equals to force into distance. So here distance is what? L is the distance. So if we will replace the force from this value and distance from the L, then we will get force is equals to PA into L, which is the length shifted up by the piston. So and we know that area into length is equals to what? Volume. So work done will be equals to the pressure into volume. So here final volume is V2 and initial volume is V1. So if when we'll replace this, or we will calculate for the change in volume, then what will we get? We will get the change in work done will equals to the at particular pressure. What happened? Volume has changed from V1 to V2. So when we will minus it, V2 minus V1, then we will get it here. Change in work done is equals to P into del V, or change in volume. So as here work done is by the system on the piston, so we will simply put here the sign negative in the case when gas is expanding. But when gas is compressed, on that time work done will be done by the piston on the gas. On that case all the equation will be same, only we will change the sign here. Okay, so all these were about the thermodynamics. So what we have seen here, that in any system energy is not created nor destroyed, it is just changing from one form of energy into another. So this is what the first law of thermodynamics states, as work done is here utilized for the expansion of the gas. So here the energy which is absorbed is involved in the expansion of the gas. So in any closed system, their energy will neither be created nor be destroyed. It just changes from one form of into another. Okay. Next thing is there, if we are talking about the internal energy, some more terms are also associated with it. One is the enthalpy. Here enthalpy is equals to E plus PV. P is the pressure and V is the volume, and the change in enthalpy will be change in enthalpy equals to change in the internal energy plus P del V. How P del V come here? We already have known. And here PV is equals to an RT. So what is an RT here? N is whenever we write any equation, suppose we are writing it here as B, and now it gets changed into the in reversible reaction, it gets changed into C plus D and D. So all this is stoichiometric property is here denoted by an, or we can say the an amount of a amount of capital A. And how we write it here during the equilibrium, or when how we express it in the chemical kinetics, we express it here as C power C and D power D by A power A and B power B. So all this value is known as an. Okay, and if we will subtract it as C plus D, sorry, small d minus A plus B, it will give you the del Ng value. So this equation comes from the osmolarity. You might have seen this equation in osmotic pressure also. If we replace this P del V with this del Ng RT, then we will have again another equation here, which is and the question based on this particular formula is basically asked. So whenever you will look about the questions from CSIR NET or GATE, you will see that the questions are very simple and totally based on the formula. So here you just have to keep all those formula in your mind so that you can easily score higher marks. And mostly such questions are asked in part C, which just by remembering these simple formulas, you can score 4 marks easily. Now, another point here is that the value of R, which is a gas constant. So its value depends on the temperature and pressure. So its units also get changes along with the change in the unit of pressure and temperature. So while solving questions, you must keep in mind the different values of the R as per their units. So here I have listed all the possible units and values of R, or which is a gas constant. So better you pause my video and note down it, so that you can have all the possible values of the R, or all the possible values of R at different units. So not only here in thermodynamics, also even while solving part A, always keep in mind that in which value or in which unit you are asking for the answer. Suppose we have calculated the answer in meter, but the question is asking in kilometer. So here what will happen, we will have the mistakes in their zeros or in decimal also. So this will create a negative marking. So always keep in mind this unit, in which unit we have to express our answer. Now move further. Del H. So what actually del H or the enthalpy is? It is actually the difference in the creation, or we can say the difference in the energy of formation of reactants and the formation of the product. So what will happen when we are talking about the reactant here, during the formation of reactants, the reactants will be converted into the product. So while formation of the reactant into product, the bonds will be broken down, so that rearrangement of bond will take place and product will form. So here energy will be required to break the bond of the reactant, and during the formation of the product, energy will be taken to for the formation of bond. So here del E is the difference in the energy required to break the bonds in the molecules of the reactant, and energy required in the formation of bond in the molecules of the product. It is just like that when we take the overall, we can say that the gross production, as we take the gross production, just like that in enthalpy also we take the net amount of energy we have used or we have been left after utilization of the energy for breaking the bond and the absorption of the energy for the formation of the bond. Okay. Yes, there are certain drawbacks about the first law of thermodynamics. So what was that? It has stated that energy cannot be created nor be destroyed. It changes from one form of energy into another. But it haven't explained why particular reactions undergo reversible reaction while other does not. Why energy passes from the hotter body to colder body, not from the colder to hotter body. Such explanation was not given. So this was given by the second law of thermodynamics. It according to this, the energy of the universe is conserved, whereas its entropy increases in a naturally occurring or spontaneous process. So any reactions which take place spontaneous will or we can say which will stabilize their energy or increases their freedom will be in the spontaneous process, while the one which is not which will decrease their independence or randomness will not a spontaneous process, as it's so obvious thing. Even if we talk about the natural behavior of any human being also, everyone want to be free. So any process which will create freedom in them or create happiness in them, it will be spontaneous. But the one which which they don't like to do in their lifestyle, if they have to do that thing, then what will be that? It will be non-spontaneous. It will be the forced work done by them when there will be at any pressure, as it's very common in the students that while examination is approaching, they start studying because there is pressure of the examination. Otherwise they remain relaxed all those times. So any process which is stabilizing any structure will be spontaneous, otherwise it will be non-spontaneous. So second law of thermodynamics also states that change in entropy of the system and surrounding, which is equals to the universe, will always be greater than zero. Okay. Entropy means what? If entropy is decreased, then orderness will increase, as orderness is related with the randomness. So obviously if you are under the pressure of the teacher, you will remain silent in the class and you will be in the ordered manner and your freedom will be decreased. Similarly, you can consider this entropy as your teacher and your freedom is your spontaneous process, controlled by the spontaneous and unspontaneous process. So entropy change in the process can be experimentally determined by the measurements of the heat, and how it is measured I will explain later on. But before that, how we will express the spontaneous of the reaction? It is specifically expressed by the help of Gibbs free energy. So how it is expressed? There are certain formulas, and questions are also asked from these formulas. Just remember all these formulas, and whenever questions is given in front of you, just read out that, make the list whatever information is given, and from that information which formulas will fit for the solution of that question. You just have to do that, and you will easily score 4 marks or 2 marks in whichever section this such questions will be given. So these are the formulas. Gibbs free energy is equals to the enthalpy minus T, and T is the temperature and S is the entropy. So change in Gibbs free energy will be equals to the change in enthalpy minus temperature into change in the entropy. Similarly, del G naught is here not expresses the standard Gibbs free energy, standard enthalpy, and standard entropy. When del G or the Gibbs free energy is negative, then the process is spontaneous. When it is equals to 0, then we can say that question is in, or the reaction is in equilibrium, and when it is in positive value, then it is non-spontaneous process. Next thing is that we express del G is equals to del G naught, which is the standard Gibbs free energy, plus RTlogK Q. What is Q here? So when suppose here is the reaction A plus B will give you in the reversible manner C plus D. So Q is the after any time how much reactant get changed into the product. So it expresses basically the forward reaction. So we can say that C into D is by A into B is equals to Q. So this expresses, and the Q expresses the at any time the suppose after time t, A plus B has changed, some amount of A plus B will convert it into C plus D. It is the reaction, or it is the representation of the equation before the equilibrium is reached, because when equilibrium will be reached, the amount of formation of C plus D will be equals to its breakdown into A plus B. Okay. So when equilibrium will reach, what will happen? On that time Q will be equals to K, and we know that del G is equals to 0. So when we will replace all these values here in this equation, we will get del G naught is equals to minus 2.303 RTlogK. Sometimes you have seen here the equation as minus RT L and K. What does the difference between the L and log K? So here during the log we represent the base value. So here Ln means log value is E, and here when we have replaced, we have put it this much value 2.303 in front of this equation. Now here E, the base value is replaced with the 10. So here the base value is 10. Okay. Another formula for the Gibbs free energy is in respect to the Faraday's constant and redox potential is del G is equals to minus n F E naught. E naught is the redox potential. In June 2017 also there was a question from this equation. I already have explained, so I am not repeating it here. If you want to see that, I have put that portion in my channel under the section of CSIR GRF NET questions explanations. You can get that link from there. Okay. Yes. A few times before I have discussed about the heat capacity, or the change in the entropy is greater than or equals to change in the internal energy by T. So how change in internal energy will be influenced? It will be influenced by the each and every individual systems, and if it is the it is expressed in terms of temperature, then it will depend the how temperature of a system is rising or falling. So it is expressed with the help of heat capacity. So if we say if we define heat capacity, then we can say it is the amount of heat required to rise the temperature of the system by 1 degree, and it is usually expressed in as C. So if Q is the amount of heat we need to rise it, and Q is the amount of heat we are providing, then what we will do here, it will be expressed as it is express a heat capacity. It means how much temperature you can rise in the system, and it will also depend on the mass of the system which we are using, and also on the temperature of the system. So or change in temperature of the system, or we can say del T. Now if we are talking about the system, then there is also work done. So work done can take place in two conditions, at constant volume and at constant pressure. So let's see first at the constant volume. So we know that change in work done is equals to P del V. When change in volume is 0, or at the constant volume, heat capacity, what will be the value of the heat capacity? At that time work done will be 0, and we, as per the equation, we know that E is equals to Q plus W, or del E is equals to Q plus W, as here W is 0. And when we will express C here with this equation, how we can replace it here? C is equals to, if we will ignore the mass of the system, then we can say Q by T. We express it here Q by T. So here when W is 0 at constant volume, because del V is not changing, so work done will be here 0. On that case, Q will be equals to del E. So at the constant volume, heat capacity will be del E by T. Okay, as here as with the formula Q by T is used. So what will happen when the pressure is constant? At the constant pressure, there will be the change in the volume, because at particular temperature there will change in the volume. So work done will be there, and we know that del E is equals to Q plus W. And if we will say it here as Q is equals to, if we replace the value of W with P dV, then we can write here Q del E minus P del V. So its sign depends particularly on the situation when work is done by the system or on the system. So we can see that this particular value is equals to the del E. So Q is here equals to del E. So at constant pressure, heat capacity will be del H by change in the temperature. So it is how we express the heat capacity of a system, which particularly controls the change in heat of that system. Now next comes the third law of thermodynamics. As per this, entropy of an ideal or perfect crystalline solid may be taken as 0 at absolute 0 temperature. So we know that if we will express the entropy del S means what? Entropy at particular temperature T and entropy at 0 temperature. So as per the definition, when there will be absolute 0 temperature, del S naught will be taken as 0. So what we will get here? Here we will get change in entropy is equals to ST, or we can express it here as Cp del T, because we know that S is equals to Q by T. Previously we have seen here from this equation. I again note it out here. So at constant, at constant pressure, because at constant pressure work done will be there. On that time, what will happen at constant pressure? We can say that at constant pressure and change in temperature by temperature, because work done will be there, so entropy will change here. Because volume is changing, it means entropy is also changing there. As obviously when we will pull up the piston, volume will change and the degree of freedom of the gas will also change. So we will express this in at the constant pressure. So at constant pressure, it will constant pressure, what will happen? Heat capacity will be considered. because it will depend basically on the heat capacity, how the system get influenced by the temperature. So we have taken here Cp, or the constant temperature. So del S, or the change in entropy, will be equals to when the temperature, what will be the change in temperature? It has changed from 0 to T, because 0 we have taken because we are considering here absolute 0 temperature. So from change from 0 to T, what will happen when we integrate the Cp del T by T? We will get here Cp log in T. It is the form, it is the way how we solve the integrations. I am not explaining it much about the integration. So when we will, as I have told, when we will replace the ln with the log, or the log to the base e to the log to the base 10, then we will explain, what we will do, we'll multiply it here with 2.303 Cp log T at particular temperature. So this is how the entropy as per the third law of thermodynamics expressed when there is absolute 0 temperature. So all these were about all the formulas. I have noted here all the possible formulas of the thermodynamics. On the basis of, and based on these formulas only, questions are asked. In my upcoming videos, in 2 or 3 days, I will release that videos, and on that I will compile all the questions which were asked based on the thermodynamics from the past year questions. I will try to compile as far as possible as more questions from the CSIR JRF net, and I will solve that for you. I know that you already can solve these questions, but even after that I will solve just to show you examples how to solve such questions. So all these were for this time. Don't forget to subscribe and share my channel, and click on the bell icon so that you can get notification as soon as I will upload my videos. Till then, goodbye and have a nice day.